Maintenance and setup of your sprayer is paramount to prevent point and diffuse source contamination. Iain explains his best practices.
The essential thing is that the sprayer is in tip-top condition. There's no leaks, there's no drips, everything is in good working order as if the day it came out the factory. All about preparation. A wet day, just check the sprayer over, making sure that everything's done, so the good days you can go spraying, everything's ready to go. The prime mover, make sure that's all in good condition, and then moving down through that, the boom needs to be straight, and that's in both axes. So there's no droop on the ends like a seagull or like a jet plane. The booms aren't like the wings, they're not dipping down, but also straight, looking down the length of them, so that you've got a good distribution of the spray pattern. The next thing to that is the nozzles on the boom themselves, making sure that they're in the correct axes. So for example, with the multi-nozzle bodies, making sure that they are perfectly aligned. Personally, I find that the milk install version of the nozzle bodies works slightly better than the windmill. The windmill version, they're just slightly a little bit, you can get them slightly out of alignment, which the way that the nozzles are designed to run means that the application might be suboptimal. Then moving on to the nozzles, making sure that they're putting the right amount out, making sure that they're not plus or minus 2%. If they're brand new nozzles out of a box and they're varying by that much, then I would send them back. That's not acceptable. But then when you do get to checking your nozzles, I personally do it on a wet day with a measuring cylinder, or you can, I know you now can get the flow checkers. A good stat that I picked up about checking nozzles is at 3 bar, whatever your nozzle orifice, times it by 4, and that will give you your litres per minute. For example, an 0.3 at 3 bar for a minute will give you 1.2. An 0.4 will give you 1.6 litres a minute. So you don't have to keep looking through nozzle charts. It's just a really quick, easy way to remember what you're doing. Changing nozzles with the policy they're now using, I find that they're really good. Even with the amount of powders that you put through them, it's still, the nozzles do work well. But by checking them, check them and then change them, not just necessarily where the flow rate's wrong, it could also be when they visually aren't putting out a nice equal pattern. Pre-orifice doesn't wear, but the actual tip does, and that can affect your patternation. You can see them all then by doing a jug check, and if they're outside 10% of the flow rate, then change them.
Choice of nozzles plays a huge part in negating contamination. I asked Iain what his preferences are.
I'm running 3 sets of nozzles on my machine. So I'm starting off with an 0.3 Defy nozzle, alternating forward and backwards. I've also got a Guardian Air or Amistar nozzle, an 0.3, and then I've got an 0.5 TTI. So a 90% drift reduction nozzle.
Iain, what are your thought processes before spraying?
Well, the key thing to me is actually applying the product at the right time. I would potentially sacrifice the coverage to get the product on time at the right time. So I look at nozzles as a bit of a flow chart. So I want to apply the product at the right time with the least amount of drift possible and hitting the target that I'm aiming at. So getting the most of the product where I want it to be. So I'm using an 0.3 Defy, alternating forward and backwards. So I tend to use that for pre-em work, if the weather's suitable, and then up to and including T0, T1s. Then I'll change over to my 0.3 Guardian Airs. But I will use my Guardian Airs for pre-emergent work, for anything else, because timing is key. So it's getting it on at the right time, and then if the weather conditions are potentially even it's windier, then I can even revert to my 0.5 90% drift reductions, but increasing, because they're 0.5s, just slightly increasing the water volume so that to offset the coverage.
What about water volumes, forward speed and nozzle height?
My default setting is 100 litres a hectare, provided that's within the label recommendations. Forward speeds for herbicides, I tend to stay between the 12 to 14k mark, usually running sort of 2 bar, around that sort of pressure. I find that reduces the drift dramatically. And then nozzle height, again, nozzle height by using the NORAC or the cable ties, 50 centimetres is crucial. Doubling the height increases the drift by tenfold, so it's crucial to keep that boom as low as like 50 centimetres above the crop. The technologies that are on there, it's phenomenal now. It's so achievable.
You mentioned the NORAC. Are there any techniques to make sure it's working in all crops?
Yeah, one of the things that I've discovered or worked with is, because this has got 3 sensors and one is directly behind the machine, so when I'm spraying oilseed rape when it's flowering or pre-harvest, and the same with beans, what I'll do is I'll turn that middle sensor off so that I have to manually control the main lift, but the NORAC can still control the wings, keeping the wings as close to the crop as possible. But then also adjusting the sensitivities so that it's not diving up and down, and just same as anything, it's the fine tuning it to suit how your driving style.
Thing we always know is drift multiplies itself so much more the greater you get above the crop. So the ability to have a consistent boom height was paramount to what we wanted to get done. And when we tried this particular one out, we found where it's got more sensors on the boom, its boom following the contours of the soil was fantastic. So we know that if we can follow the boom low to the soil, we can reduce drift. If we reduce drift, we get more chemical to where we want to be. So now where we used to follow aim to get to 50 centimetres above the crop, we now go down to 40 centimetres. And now we can actually go lower than that. Now we can now down to 30 centimetres above the crop quite confidently, and the boom will look after itself. But when we get to those sort of heights, the standard 50 centimetre spacing is just too wide, the risk for striping in the crop. So on this particular one, we've got our standard 50 centimetre ones, and then we've got intermediates at 25 centimetre ones. By doubling up the nozzles, we've got the potential to actually get a better spray covering going at a lower height, which is reducing drift. We're getting more of our money's worth of chemicals where it should be, and not out of control into the environment.
I see you've got 03 nozzles in here, John, and my maths tells me that if you halve the nozzle spacing, the volume's going to go up.
Logic would say is you would have to go for something that a 1.5, but in the practical scenario we thought the 1.5 would bung up. So in this situation where if the time is right, we want to go, but the wind is too great, we could wait until the wind drops, which might be 2 or 3 days later, which means we can get the application right, but we miss the timing. So if it's like that, what we can say is, do you know what, rather than putting 100 litres a hectare on, we'll stick with the 03s, and we've got 03s on the main nozzle and on the intermediate one, and we'll put 200 litres of water on. And so our actual droplet size, although we're going to have a bigger droplet because we're on an air induction nozzle, we're going to have twice as many droplets anyway, so therefore the chemical to drop ratio to what we get onto the plant still works out about right.